Hello, welcome back to chapter 2 about the classes. With this lecture, we will continue our discussion about the basic information for class. Last class, we introduced that a class has two parts, attributes, or we call it instance variables, and behaviors. And we call them instance methods. And also we discussed an important concept in object-oriented programming about encapsulation. And encapsulation is about the accessibility of instance variables, attributes. So it's try to protect the attributes. So we use the keyword private. Okay, so because of the protection of the attribute or instance variables, so but we do need to do some operations on the object. So we provide the instance method. So instance method or behaviors, we can also call them, it serves a purpose of interface between the attributes and the behaviors. And generally speaking, instance method or behaviors, their accessibility, or we call it visibility, is public. Well, that means it allows external world to access the private instance variables. Depends on the designer. Okay. And also, generally speaking, about instance methods, there are generally considered two parts, two categories, accessors and mutators. And accessors basically are get methods. And mutators are set methods. And of course, we also have constructors. Constructors is used to create objects. Okay, so we will discuss the first types about accessor or getter methods. Okay, uh, so they are instance method that's only retrieve the value. Okay, be careful. They are not so they are not modify the value of instance variable. So the purpose is to allow to safely exposure the value of encapsulated variables outside of the class definition. Okay, and the way to invoke an object instance method is you create an object. The object has a name. Then using the dot to access to following the dot is the name of the instant methods. As previously we just discussed, accessors only retrieve values. So they will not modify. Okay. And uh, it provide at a certain level some safe encapsulation. Okay. So we need to make sure that our accessor will not modify the values. So just be careful because later on we will also say there are some variable reference, okay, or value. There's some difference between that. And if we are not careful, even though we only do accessor, external users can still modify the instance variables. So then it doesn't provide the protection. So that's regarding the consideration of how do we perform secure coding, okay, for encapsulation. So here it's a kind of provide the diagram to show, okay. So in the P1 type is a person object. Okay, so it's created from that person class. So it does have like a name, age, um, a weight, and a height. Okay, and um, so if for the accessor, okay, like the get name method, so it will return like the name instance variable. So then will you be able to modify it like this diagram shows? Suppose initiates if default and then change it to default bad. And then like this diagram shows it's impossible. Okay. So later on we will explain our example why we cannot, because what this method going to return is also a string type. Okay, string type. So why it won't? Because what you do is you return your M name, return that mm, instance variable's value. Okay, but the issue why you cannot, it's impossible to modify it, is because string, this data type itself is immutable. Okay, so even though it's a reference type, but you will still not be able to change it. But if we change the type, like get name, we change it to char array. Okay, like a get name. And suppose your M name defined as char, is a char array type. Then when you return the M name, so what you return, this is a reference. Okay, so on heap memory, it's the memory location of that M name. Okay, so then in this case, if you change it, then it will be successful. Okay, so this is, if it is this case, then this will have a security issue. Think about if it's databases, then it will have a security issue. So we needed to be careful. Okay. So we already explained the concept of encapsulation is to make the instance variable private, okay, and safe encapsulation so that to make sure external user cannot directly access instance variable. But so then the instance variable type is very important. It depends if it's a reference type or it's primitive type. Okay, if it's a reference type, if you do want to protect it, you need to make sure the object type is immutable. Otherwise, you will still, the instance variable will still be able to get exposed. So there's going to be a security hole, okay? And so the accessor method is also public, so we already know that. And also, we only expose, so not every instance variable, when you design the class, you will make it public accessible, provide a accessor method. It's not that case, okay. So it depends. So if you want a user to do something, okay, to see it, to view it, then you provide the accessor. The second type of instance method is mutator, or we call it a set method. Okay, so those methods, if you do want to modify the value of an instance variable, so then you take, so that's why we also call it a mutate, because you do modify, okay? But also we needed to be careful preserving the correct state of object. So here, once again, to involve like reference type, it's you need to be very careful regarding security. Okay. Yeah, so here is more discussion about like mutator and safe encapsulation. Yeah, so is that even though we provide a mutator, but we still need to make sure we don't want a user to take advantage of security hole. Is that so when we design the mutator, the set method, we don't want the case to be happened and to error to erroneous change object instance variable to some illegal illogical or bad values. Okay, so we do need to perform certain checks on users input. Okay, so be careful. And here is give some examples about numeric primitive data type, about string, about objects. Okay, some bad values. Okay, so in that person class, so we did provide a mutator like a set name. So that name, the parameter type is like suppose it's another name, is it? And the return type can be void. Okay, yeah. So what you did do is you set the instance variable to the parameter. And previously, we also said string is immutable in Java, okay, in Java. So when you first do mname, you assign it to default. So this is on heap. So a certain block of memory, so certain bytes of memory is reserved for this block, okay. And then later on, you said, okay, p name is A, B, C, D, is it? So it will take another block of memory. So this is basically the P name, okay? So then you assign M name to P name. So basically that M name, like in this diagram show, is going to point to this P name here, okay? So then this default, you see, then no variable basically point to this block of memory anymore. So then obviously it's kind of a dangling. So just some a block of memory that's allocated, but no one can access it. Is it? So it take up computer resource. Over here, mainly it's memory. Is it? So, generally speaking, in programming design, we don't want this kind of scenario happen to too many. If too many, then the heap memory can be completely occupied by this those memories. Then, if you do need to do like the new, then no more heap memory available. You don't want that to happen. Is it? So in C++ or C, we have manually way to handle this kind of situation. We call it to release the memory back to system. Okay, we do the deallocation of memory. Okay, but in Java, so Java machine take care of this. Okay, we call it Java garbage collection. So Java garbage collection will automatically take care of those intended string object and free up the computer memory. So they will be freed, okay, by Java virtual machines garbage collection. So the Java garbage collection, so it does prevent the memory leak issue. So to free up the computer memory, this we call it does prevent memory leak issue. So this is a security consideration. But in C++, if like you as a programmer, you design and you forget to do that, that will cause a memory leak issue. Okay, so a summary about the accessor and the mutator is we do have the private keyword to perform the encapsulation for objects. And how do we provide a safe encapsulation? So we decide, okay, how to access instance variable, okay. And also remember mutator can modify the instance method. Generally speaking, accessor wouldn't allow you to do that, but it also depends, okay, the instance variable type. How do we truly achieve the goal for the encapsulation? So the next section in this chapter is about the keyword of is, this, okay? So this refers to object itself. So it refers to object itself, okay? And inside the class definition, all instance variable and methods can be accessed using this keyword to specify, okay? Just like the previous case for the person, then inside the class, you just do this dot, then like m name. M age, M height, something like that. If you do want to access a method, then you can do this like a get name to invoke it. And normally we see we don't do this within the class definition, okay, because it's already scoped within the class. But if sometimes when you like have the method call or the instance variable access, you want to really make sure that it refers to which object, then you can explicitly put this ahead of the instance variable and name. And because of over here we mentioned object itself, so there comes some terms, okay, a clone, aliens, and original, okay. Uh, aliens basically refer to the same object on heap, okay. So the idea is like this. So here is our heap memory. Okay, and here is that stack memory. So we have that P1 is a person, and so we do like a new person. Here's a person. And the P1 then, okay, so this statement should be somewhere, okay, but what I mean is the P1 variable itself is on stack. So what is this new call, as in this new call, then it will create a block of memory on heap, then with like a name, like M name, M age, something is, and the instant method is it all, so it's referred to somewhere. And then later on, suppose you do something like this, person P2 equal to P1, is it? Then what this P2, it will also refer to the same memory block. Okay, so basically you can call P2 aliens. So P2 is aliens of P1 because basically they two refer to the same object. Okay, and the P1 in this case is the original. Okay, so what clone? Clone means suppose then you are going to do like a person P3, okay, you also do new person. So then it will have a block of memory a block of memory that on heap. But what it will do is it will have exactly the same. So the name will be the same, the age will be the same. So all of the values will be the same, will be the same. So, but it on its own memory block at its own memory location. Okay, but they share the same value of the instance variables. Okay, so then in this case, it is a clone. Okay, we also call it a deep copy. So clone means a deep copy of the object. So in this case, P3 is a deep copy of P1, okay? And P2, aliens, we also refer it as a shallow copy. So P2 is a shallow copy of P1, okay? But here also needed to be careful, okay? For our person's case, the instance variable are either immutable or primitive. So then we just do the value copy, that will be fine, okay? But if it is a reference type, suppose it's array, then the case is you cannot just do a reference copy, okay? You need also to make a deep copy. So if instance variable is reference type, okay, then you need to make a deep copy. Deep copy for clone of the class. Okay, later on we have example. We will see that this concept. Okay, so be very careful about this because otherwise that will also cause some security issue. Okay, regarding like secure coding, we call it aliasing problem. And a further discussion like aliasing or clone, etc. So over here it says, okay, this James clone or Jane clone is a clone of Jane, etc. So if clone's age got changed, then it won't impact Jane. Okay, so if its age change from 10 to 11, it won't change. But Jane aliens, okay. Jane aliens and Jane basically they point to the same location. So if you change Jane alien's age to tell, and basically Jane's age also change to tell. So we need to be very careful about this. Okay. So this in secure coding we call it aliasing problem. So we already discussed the difference, okay, and you can take a look at this table to summarize the difference between clones and aliens and originals. There are some other instance method. We call them tailored instance method. Okay, uh, they basically can be categorized to either accessor or mutator. It depends if you are going to modify the values of the instance variables. Okay. So over here, it says the classes, generally speaking, they receive some default from object superclass. And in Java, object is a class, is a superclass of all of the other class. Okay. And the object has a number of instance methods. And generally speaking, regarding other classes that you create, then we call them some default method, default implementation. That, for example, that one toString method. Okay, so object class does have a toString object, but that toString object. Uh, what it does, it's just return some heap memory address of the object. What we want the toString object class method to do is we want it to output of the related information about this object. Is that so that we get an idea, like for the person class, you want to know the name, age, weight, and height, etc. So if you design a method that can output those information, then that will be very helpful because once you do that print, okay, or print line of that, like suppose Jane, etc., or that P1, then it will automatically call the toString method of the person class. Then it will output directly of the related information so that you don't need to explicitly do like P1 dot get name and get age, call them. That's kind of trivial, is it? So in order to save all of those trivial work, you can group all of the output information to the string method. And when we discuss like the toString method is some Taylor instance method, then in this section there is another concept very important. It's regarding referential equality versus structural equality. Okay. Basically, for referential equality, you use a comparison operator to do the compare, is it? So in the previous case, if you recall the person Jane, is it? So Jane basically and the Jane aliens, these are referential equality. So it is true because they refer to the same object and same memory location on heap, is it? So aliens is referential equal, okay? And so this is regarding shallow copy equality check, okay? When you do structural, it's not just, it doesn't matter if uh, uh, the memory location is the same. What they care about is about the contents, like a name, age for the person object. Is it they can be exactly the same, but they are two different person. So that's regarding contents. So it's more about deep copying. Okay, so we do need to know the difference between these two, okay? And in Java, the object method also has a method called equals, okay? And this equal, it should test for structural equality, okay? So the same memory location is not required, but they do need to check if the contents are the same. And of course, need to be the same type. Okay. Same type of class. So that's a must. So here to give us an example is it, so test one is that person, and test three also refers. So both of them point to the same. Okay. And so basically, test three in this case, as what we previously also discussed, is an alias of test one person. Okay. Or it's a shallow copy. And also, but for test two, then it is a clone of test one. So it's a deep copy, test one, okay. So a lot of time we also, when we create a class, we also override the equals method. Okay, so the equals method, the parameter type, you can see it's an object. Okay, the superclass object. And but superclass equals only check for referential equality. It doesn't guarantee the deep copy. Okay, but we need to implement the way that it guarantees the structural equality. Okay, so we will see in our examples how we tailor this instance method. So here's uh, the implementation regarding that person's class. Okay, so the parameter type is object. So you do first need to make sure the passed new object is not a null object. Okay, and then you also need to check if it is the same class type. So check if it is the same class type. And to check that, we can use Java's instance of, okay, to do the check. And if it does, because the type is object, so then you cast it. So here we do cast to the specified class, okay, to our class type. And after that, then you need to do, you see, you need to do check. So check values. So basically, we can also say we check structure equality. Because from primitive values, uh, um, it's it's the structure equality. Okay, but for reference type, so that's why over here I put structure equality. We also want to make sure it's a deep copy, not the same memory location, because otherwise it can cause some memory issue. Okay, so that's the kind of like the conceptual explanation about this new section materials. Okay, so we will stop here for this lecture.